produced and by what? The draft is produced upstream of the combustion zone of the appliance by the mechanical device, usually a fan.
Here it said forced draft, okay? So in the forced draft, where the combustion happened is after the fan, right? Okay? The combustion, forced draft. And inducer draft, where the combustion happened before inducer, right? Okay, so upstream and downstream of it. Thank you. Okay, Mr. Su, would you read number 2, please? Mr. Su, yes. It said that the simplified formula used to calculate the theoretical draft. We explained regard to that draft, right? We said the draft is directly depend on the h, the height, right?
Yes.
So as the height of the draft increase, the draft will increase, right?
Yes.
How about what's TS?
TS is an increase and the draft rate increase.
Okay. This average static, right?
Yeah.
And what's TA?
TA is an increase and the D is a decrease.
Decrease, ambient, right? Mr. Jen, number 3, please.
When will draft be greatest? When the average stack temperature is greatest, when the outdoor air temperature is least, and when the stack height is greatest.
Yeah, that's what we thought. When D is increased, H should increase, TS increase, TA decrease. Okay, that's what. Thank you, sir.
Thank you.
Okay, Mr. Amandip, number 4, please.
How is average stack temperature determined? It is the average between the temperature at the flue collar and the temperature at the vent termination.
Okay, the average temperature between those is going to give you a stack temperature. Thank you, sir. Mr. Victor, number 1. Okay, number 5, please.
Okay, to extract heat from flue gases, what would be installed? A heat reclaimer.
What's heat reclaimer mean, sir? Number 1. What's heat reclaimer?
Heat reclaimer is a device that may be installed external or internal to the venting system to extract heat from the flue gases.
Can we use it in residential?
No, sir. Only on industrial.
Yes, big industry.
Yes,
thank you. Mr. Pressure?
Number 6, sir. When capacity is exceeded, what happens? Some product combustion spoil from the draft code of the appliance.
Okay, when the capacity exceed happen?
Yes, some product combustion spoil from the.
Thank you. Mr. Hamid Ahmadi, number 7, please.
Sir, number 7 is why does a venting system operate? Because there is a draft.
Because there is a draft. Okay, there is. Please, everybody, open your code book, page 117. And I want to see 8.1, venting system and air supply.
Okay, venting system and air supply for appliances. 8.1.1, the requirement of the clause 8.2 shall apply to the central heating furnaces, boilers, and hot water heaters. 8.1.2. Okay, the requirement of clause 8.2 to 8.5 shall not apply to direct vent appliances. Note, regardless of the category type, when an appliance utilizes indoor combustion air, it is not considered to direct vent appliance.
Okay, direct vent appliance, sir, those appliances which we use 2 pipes, one inside and the other one out, usually is 4-inch and 8-inch or 4.5 and 7-inch. Where the front, the inside one, you take the exhaust out, and from the surrounding, from around between those 2 pipes, it brings the fresh air. So this module that we right now, this class number that we read is not regard to those 2, because now we're gonna check for the combustion air, and that one, the combustion air already coming in. Okay, so 8.1.3.
8.1.3, interference with the air supply for an appliance shall be prohibited. 8.1.4 air supply shall be provided in accordance with A. Clause 8.2 and 8.3 when either an appliance or a combination of the appliances has a total input of up to including 400,000 BTU or 120 kilowatt, or B. Clause 8.4 when either an appliance or the combination of appliances has a total input exceeding 400,000 BTU.
Okay. On this one, we say that the clause number 8.2, 8.3 is regard to the appliance less than or up to 400,000 BTU. And more than that, we're going to go to clause number 8.4. Okay? More than that, we're going to go to clause number 8.4.
8.1.5.
Yes, please.
When an appliance other than a central heating appliance or a domestic water heater is installed in a location where there is insufficient air for combustion, provision shall be made to provide an air supply size in accordance with the table 8.1 or 8.2. 8.2 air supply determination for central heating furnace boilers and hot water heaters. 8.2.1 an outdoor air supply size in accordance with the clause 8.2.2 shall be provided for an enclosure or a structure in which an appliance is installed when the enclosure or structure A has window and doors of either closed fitting or sealed construction and the exterior walls are covered by a continuous sealed vapor barrier and gypsum wallboard, drywall or plywood or a similar material having seal joints. B has an equal leakage area of 78 square inches, 0.05 square meter or less at a differential pressure of 0.00145 psig, 10 Pascal, as determined by the recognized Canadian fan depressurization test procedure.
Okay, sure. Let me explain it. Okay, this clause number, please, everybody remember it. From now until the end of 3 weeks, all the time, we say clause number 8.2.1, section A and B. 8.2.1, A and B, okay? Please, you have to remember it, you have to memorize it or whatever. If you do not understand, please don't let me to pass, let me repeat it over and over until you get it. Okay, this one you talk about, it said if you have a structure, with this structure, we put the doors, windows, and seal them, put caulking all around, and the wall, you put plywood, insulation, drywall, and all been sealed, okay? So this type of structure, it means tight house. All those new houses is considered as a tight house. Please make sure and understand this one. All those new houses is considered as a tight house. So when we mention that we install the appliance in the structure, comply with clause number 8.2.1 A and B, it means that we install the appliance in a tight house. And if we mention it, we install the appliance which is not complied with clause number 8.2.1 A and B, which it means the loose house.
8.2.2.
Mr. Michael, would you explain this clause number 8.2.1 A and B?
8.2.1 A and B is for an older house, right? It's a loose house. And for a newer house, it's a tight house.
I will explain it right now. Okay, look at this 8.2.1. It said all regard to this structure. Okay, all these two is regard to this structure. What types of structure? Either enclosure, close, or it has a window, door, closed fitting, or seal construction. Michael, you work in construction, right?
Yes, sir.
How do you seal door and window?
Caulking, or sometimes we use like a foam, right? Or
Yes, sir. So
a
you put
special
a
caulking or
foam and
vapor barrier.
vapor barrier. Great.
Or we use this tape, the red tape, tuck tape.
Red tape, where you put it?
So you tape the joints, or you tape the edges of the vapor barrier around the window frame, like a picture frame. You know what I mean? And you.
So these are also when you do it and seal vapor barrier, gypsum wall board, okay, or drywall, plywood. These are all to seal, okay, to prevent the heat going out.
So can we say like finished or unfinished basement or a house?
Yes, sir. Now, he said has equivalent leakage area of 78 inch or less differential pressure. Okay, differential pressure passing when it's tight, it won't any pressure between indoor outdoor, right? This is the differential pressure. It won't get the negative pressure. Do you remember 0.02? We had it previous 5 Pascal. Okay, and he said here at least the differential pressure of 10 Pascal. Depressurizing test procedure. We will go through this depressurizing DP so many times, okay? So if we got depressurized or differential pressure more than 0.02 is going to be negative, okay? So this depressure it should be less than this 10 Pascal, okay? Anyone has a question? Yes, go ahead.
Yeah, this differential is the difference between inside house and outside house, right?
Differential, yes, sir.
So only thing is not clear a little bit, if you can clear a little bit more, is the leakage area, which is 78 square inches. That means it's like a square inches anywhere area completely in the whole house. That's what you mean?
Yes. The leakage. You talk about leakage, sir. Okay.
Cannot be more than that in whole house. 78-inch square.
Leakage.
In whole house.
Yes, sir. Exfiltration. Okay. So please remember this class number here, 8.2.1. When it said 8.2.1, it means, okay, tight house, okay? 8.2.1, A and B, it means tight house, okay? Thank you. Now, Mr. Khalid, can you still continue? You don't mind?
Yeah, sure, that's fine.
Okay, would you go 8.2.2, please?
Okay, 8.2.2, except as permitted in clause 8.2.3, the free area of the outdoor air supply required by the clause 8.2.1 shall be determined from table 8.1 for an appliance having a draft control device and from table 8.2 for an appliance not having a draft control device, using the total input of all appliances in the structure or enclosure. If an appliance with a draft control device and an appliance without the draft control device are installed within the same structure or enclosure, the required free area of the air supply opening shall be the greater of A, that required by the table 8.1, using the total input of only those appliances having a draft control device, or B, that required by the table 8.2, using the total input of all appliances.
Okay, so to understand this clause number, first we have to read table 8.1.
Okay.
Okay, let's go table 8.1. Here is table 1. Would you read the top of it, please?
Okay, the combustion dilution air requirement for appliances having draft control devices when the combined input is up to and including 400,000 BTU and the structure complies with the clause 8.2.1 A and B. That's talking about the tight house.
Yes, sir. So in this table, it gave you three data. First, it said calculate what? Combustion dilution air. For what? Having draft control. So first, we have the appliance natural draft with the draft control. Second, total BTU is not exceed than 400,000 BTU. And third, it is installed in a tight house. So you got it?
Yeah, three things.
Please write a note regard to these I'm talking about, because tonight I make it easy. If you don't practice it, by the end of third week, you forget it again. By the end of the course, you don't remember it. And these are important, okay? I give you an example. Everybody understands so far this table what's regard to?
Yes, sir.
This is regard to for natural draft, we need to calculate combustion dilution air, the amount of air which we need for combustion primary, secondary, and dilution air. For which appliance? Appliance which is draft, has a draft control. Natural draft, okay? What appliance? Appliance up to 400,000 BTU. And which structure? Tight house. Comply with 8.2.1 AMB. Everybody understand? Can I go next?
Yeah. Sir, what was the note you said you wanted us to write down?
Sir, about this three information, okay, this table, regard to this, they will ask you what's the table 8.1. Table 8.1, regard to combustion dilution air and reserve, okay? Now, please, I want you to have a ruler. Please, I want you to have the ruler, one ruler, piece of paper, okay? Piece of paper and pen or pencil. Everybody got it? Please write it down. I have appliance and furnace, which has draft control, and the BTU input is 80,000 BTU per hour, and install it in a house which is comply with 8.2.1 AMB. Please find out the opening required for combustion dilution air. Okay, this one I'm gonna solve it, and we go to the next one. First, I gave you, I said draft control. I said 80,000, and I said tight house. Okay, so on this one, we go, sir, here. 80,000, we don't have it, so I go to, I put my ruler in front of, put my ruler front of 100,000 BTU, okay? What I got on the second column here, it said required free area opening duct inch square. Inch square is a square one. And the third column, it said round one. It gave you the diameter, the round duct. Mr. Khaled, he has a new houses. Okay? So, is he allow me to make an opening hole, a square one? No, sir. But he doesn't mind if I make a round one when I explain that it needed for combustion. Okay? So here, I have that furnace. I need 14 inches square, 2 by 7, 3 by 4, opening or round one, diameter 4-inch pipe. Usually we get 4-inch pipe, we bring it from outside and we leave it in the combustion, in the furnace room, in the tight house.
4-inch pipe?
Yes, sir.
Yeah, thank you.
So, sir, Mr. Amir,
Yeah.
on the new houses,
Yeah.
okay, is tight house, okay? So
Right.
when you have a furnace room and you have a hot water tank, if your hot water tank or another appliance is inside and is a natural draft, so when the inspector comes, he will make you to make an opening, bring one pipe from outside, those flex one, and leave
Yeah,
it in,
flexible. Yeah.
okay?
Yeah, sure.
For combustion air. You got it?
Yeah, yeah, yeah.
Practical
100%.
too, okay? May go to the next, please. Yeah, you don't mind to read the next one too, please? Table A2.
Which one is going to be 8.2? Okay.
Table A2, please.
Yeah. Combustion air requirements for the appliances not having a draft control devices when the combined input is up to and including 400,000 BTU at 120 kilowatt and the structure complies with the clause 8.2.1 A and B. Okay.
Okay, so right now this table 8.2 is the same as table 8.1, except here.
Yes, sir.
Here we have combustion air, no more dilution. Why? Because here is fan assisted, having no draft control, fan assisted, and is up to 400,000 BTU and the same tight house. So the only difference is without draft control. It is fan assisted, it's not draft control. So we see how much air for combustion do we need it. Again, if I do have a hot water tank, 120,000 BTU without draft control, what is the opening for combustion air? If the structure is comply with 8.2.1 AMB.
How much is the BTU?
120,000
4 inches.
without draft control. Please write it in your chat if you want it. I'm gonna explain this one, but the next one is a little complicated. I'll let you to do that.
Both of them included.
Okay, so this one, we say 100,000, 120,000 without draft control and comply with 8.2.1. Then we go table 8.2. We come here, 120, 100. So I have to go to 125. Put my ruler flat of it. It's gonna be 9 inch square one, and equal to 4 inch round one. Everybody understand it?
Yes, sir.
So please, let's go to the next one. I want you to do this, solve this problem, okay? I have two appliances. One is the furnace with 100,000 BTU with draft control and hot water tank, 140,000 BTU without draft control. What opening do I require for this structure if it is comply with 8.2.1 AMB? One furnace, 100,000 with draft control. One
4 inch.
water tank, 140,000 without draft control. Both comply with 8.2.1. To solve this problem, you have to read this 8.2.2 that we done it before. 8.2.2. You have to read it carefully. Do you want me to explain?
Yes, please.
Okay. Look at sir. In 8.2.2, it said if you have two type of appliance, one with the draft control and one without draft control, one with draft control and one without draft control, and both in structure comply with 8.2.1 A and B. Now we need an opening. What opening should we have? Okay, so first we go on table 8.1 for those are with the draft control. Table 8.1 with the draft control, it was 100,000.
Yeah,
What we get 4 inch.
4 inches, that's correct.
Okay, then B it said, so on the B it said that now you add both together, total input. It meant that 100 plus 140, 240,000.
5 inch.
Then you go 240,000 on table 8.2.
Mm-hmm.
For 240,000, you go 250. For 250, you got 5 inch. Okay?
Mm-hmm.
18 and 5. Now you compare 18 by 5 and the second one, 4 inch. What was 4 inch and?
14.
Yeah, 14 and 4 inch. Whichever is bigger is the answer. 18.5. 18 and 5
That's going to be
is the
answer.
answer. Okay? Give me a second. I'm going to draw you the picture. Now listen careful, okay? This is the tight house. In the tight house, I have furnace room. In the furnace room, I have 2 appliances. It has a draft control, one without draft control. The draft control is natural draft, okay? Now the second one is fan assisted, okay? Not draft control. The fan assisted, it has a fan, okay? Or vent one. And this is the exhaust. It's going to the B wind. Okay, this 2 way. But right now, what we talk about this area. Combustion.
Recording in progress.
Okay, you got it, sir? We explain it. If you go back, read 8.1.2, you say the requirement of the class 8.2 to 8.5 shall not apply to the direct vent appliance. And I read it first, and I ask if everyone understand it well. I'm gonna repeat the question. Okay, so let me repeat this question again. I had 2 appliances, sir. Was with this one, sir, with draft hood. With the draft hood here, how much was it? 100,000 BTU, MBTU. And the second one, without draft control, how much was it? 140,000. Now, we say this is in a structure enclosure, which is tight house, which everything is closed, okay? Mr. Michael, he was doing the renovation of this house, okay? And Michael, he put everything here, okay? He put those drywall, he put vapor barrier, he put everything, okay? Gypsum wall, drywall, everything. So no air, it can enter or exist, okay? He made the way this wall air-proof, nothing cannot. Okay, since there is nothing can come in, I need the air for combustion. I need to burn those air for these 2 appliances, okay? And now you tell me, where should I get that air? I have to bring it from outside. Combustion dilution air from outside. How bring it? I have to make an opening. Now the opening that you made, either you make it a square one, a square like this one, sir, okay? Make it a square one, or you make it the round one. I make a square one for you, okay? Is it clear? Now this size, I go first on table 8.1. Table 8.1 for 100,000 BTU. What I got? 14 and 4. And table A2 for 140,000. What I get? Then I have to add them together. By which class number? Class number 8.2.2. I add them 100 plus 140, 240, 240. I go, it's 250. For 250, 18 and 5. So 18 and 5 and 14 and 4. Which one is bigger? 18 and 5 is the answer. 18 square, 5 inch round. Mr. Muhammad Ali, now you
Okay, yes,
listen.
sir. Okay.
First, you go on table 8.1 and only those are with draft control. It means only this one. Only you look at that one, it has a draft control, sir.
Yes, sir.
Okay? Only this one, sir. You look at this one on table 8.1, you get 14.4. 14 square and 4 round. Then it's
Correct.
on table 8.2. Then you add them together, 100 plus 140, and go to table 8.2. Now you go to table 8.2. Okay, let me repeat it one more time. So on class number 8.2.2, it said that the first they require the table 8.1 using the input of only those appliances having draft control. Only mine here draft control is 100,000. 100,000, I go to table 8.1 and I see it's 14 inches square and 4 round. Then it said B. They're going over table 8.2 using the total input. Then I add them together. 100 plus 140 is 240. I go on table 8.2. Okay? And I see 250, 18.8. Whichever is bigger is the answer. 18.8. I need you to do class number 8.2.3, 8.2.4, 8.2.5, 8.2.6. Especially, I emphasize 8.2.6 and table 8.3, 8.4. These are, I want you to do it for tomorrow night, okay? I want you to read it tonight and go through those class number.
Okay, sir. Sorry about it. May I have last question?
Yes, sir. Go ahead, please.
Yeah. As you said, if we compare the two table and natural draft one size is bigger than the total one, so we choose a bigger one?
Yes, we choose the bigger one.
Okay, sure. That's it. Yeah. Thank you.
Yeah. Tomorrow night, I give you another question, which the natural draft is bigger one. Okay?
We can discuss.
Read 8.1 and 8.2 and 8.3 and 8.4.
Yeah, read the class number slowly and understand. When you read it properly, you will understand. It will be very easy. Otherwise, it's going to be hard.
Mr. Shita, listen to me. First, you go on table 8.1 and look at this draft control. Okay? Draft control, you go on table 8.1 and see what's the answer. It gives you 14 and 4, 14 inches square.
I find it, 14 and 4.
And 4.
Yeah.
Then you go.
Yeah.
Add them together. 100 plus.
Yeah, 100 plus.
140.
Yeah, 140. Yeah.
Equal 240.
Yeah, 240.
Now you go on table 8.2.
Okay.
And see, it gave you 18 and 5. It's 250 and 5. Now, which one is bigger is the answer.
Oh, okay. Now I got it. Yeah.
Thank you, sir. Thank you.
Yeah.
Thank you.
Thank you, sir. Have a good night.